I'm an educator from Kajera International School for Physics. My name is Ruchikumari Kaushik, and let's start our today's topic, which is Coulomb's law. Before starting Coulomb's law, I have to tell you about charge. Now, what do you mean by charge? As I have already written the definition for charge, but we have to understand the meaning. What do you mean by charge? It is an elementary property of every elementary particle. Now, what do you mean by elementary particle? If someone asks you, then what you have to answer? Now, we have a building, and in that building we have a building blocks, and that building blocks is known as elementary particle. If we are talking about atom have elementary particle like electron, proton and neutron, and that every elementary particle we have a charge. As you know that for electron there is a negative charge, for proton there is a positive charge, and for neutron it is electrically neutral. Now we will start the interaction between two charges. Whenever the like charges or the unlike charges come in interaction, or they are separated by some distance, there is some force. It's depend on their charges that there is a force of attraction or there is a force of repulsion. As we know that like charges always repel each other and unlike charges always attract each other. I hope you know that what do you mean by like charges and what do you mean by unlike charges. I hope you know that. If you don't know, let me repeat again. Like charges, which means that positive, that is like charges. Negative, that is like charges. And if we are talking about unlike charges, that is one positive charge and the other one is negative charge. So, according to the situation, according to the charges, we have two types of forces, which is force of attraction and force of repulsion. So, between like charges, we have force of repulsion. Between unlike charges means positive and negative, there is a force of attraction. As we know that force is a vector quantity, it has magnitude as well as direction. So, how we can calculate magnitude of forces between two charges? So, we have a formula, the force of attraction or the force of repulsion between two charges is directly proportional to the product of magnitude of charges. Let's suppose Q1, which is a scalar quantity. I have written here quantity which is Q1 3 into 10 raised to 6 Coulomb. Coulomb is the unit for charge. Let's suppose Q2 is 10 raised to 6 Coulomb. There is another charge. So, force is directly proportional to the product of two charges and it is inversely proportional to the square of the distance between the two charges, and the distance is here r. So, we can write F is directly proportional to 1 by r square. Now, if we are combining these two equations, we are getting another equation which is Q1 Q2 by r square, and you know that whenever there is a directly proportional, if we are converting that proportional sign into equals to sign, then we have one proportionality constant. Now I am writing here K, which is our proportionality constant, K Q1 Q2 by r square, and I am again writing here F. So, we are getting formula which is F is equals to K Q1 Q2 by r square, where Q1 and Q2 is the magnitude of two charges and r is the distance between the two charges. Now, we have force which is a vector quantity. This is the formula we are getting for finding the magnitude of charges. Now, how we can calculate or how we can find the direction of any vector quantity? So, Coulomb's law states that the direction is always along the line joining the two charges. The force can be repulsive, so the direction of force will be here. Why here? If this charge is larger, then this charge will push Q2 towards the right hand side. Okay, so the direction is always along the line joining the two charges, and here we have completed that Coulomb's law. Now we will solve one numerical, which is according to, we have to solve Coulomb force. Okay, now let's try to solve it. Okay, let's have one numerical. Calculate the force on charge, which is 3 into 10 raised to 6 Coulomb due to another charge of 1 into 10 raised to 6 Coulomb. We have one charge Q1, which is 3 into 10 raised to 6 Coulomb, and the another charge Q2, which is 1 into 10 raised to 6 Coulomb. Okay, now if the distance between charges R is 100 centimeter, whenever there is a distance which is in centimeter, you have to convert it is into meter. So 100 centimeter, which is equals to 1 meter. So we have to calculate the force. We have formula F is equals to K Q1 Q2 by R square. K value is 9 into 10 raised to 9 Newton meter square upon Coulomb square. Now we have to substitute all these value in this equation. So we will get force, which is 9 into 10 raised to 9, Q1, which is 3 into 10 raised to 6, into Q2, which is 1 into 10 raised to 6 upon 1 square. So we have to calculate what we will get. 9 3s are 27 into 10 raised to 9 plus 6, which is 15, 15 plus 6, which is 10 raised to 21. So we have a force which is 27 into 10 raised to 21 Newton. We have the units of force, which is Newton. So here we have completed our topics. I hope you enjoyed my lecture and have a good day. Thank you very much.